Hello, everyone. I am Professor Bu-Sik Kang, and I will be teaching the Hydro Remote Sensing course at Dankook University this semester. You might be surprised to hear a different voice. This lecture video was created using a text-to-speech converter, TTS. First, I am pleased to explore various aspects of hydro remote sensing with you this semester. Remote sensing has become an essential tool in various fields, such as environmental monitoring, disaster management, and resource exploration, thanks to advancements in modern science and technology. Specifically, hydro remote sensing plays a role in the efficient management of water resources and sustainable development. In this course, we will cover a wide range of topics, from the basic concepts of remote sensing to the latest technological trends. You will learn how to collect data from aquatic environments using various platforms such as satellites, drones, and radars, how to analyze this data to solve real-world environmental problems. I believe that your active participation and curiosity will make this course even more meaningful. I look forward to us learning and growing together during this semester. Thank you.
First, in today's lecture, I will guide you through the textbooks we will be using this semester. In the Hydro Remote Sensing course, we will be using a total of 3 main textbooks. These textbooks have been selected to help you gain a deep understanding of remote sensing and GIS. The first main textbook is Remote Sensing and Digital Image Processing. This book, authored by Professor Jensen and translated by Professor Lim Young-ho along with other experts, comprehensively covers both the theory and practical aspects of remote sensing and image processing. This is the 4th edition, reflecting the latest information and technologies, and it is an excellent resource for approaching concepts step by step, from the basics to advanced levels in remote sensing. The key concepts and practical content you will learn in this course will be systematically covered through this textbook. The second supplementary textbook is Making Spatial Decisions Using GIS and Remote Sensing, a workbook. This workbook, authored by Karanen and Colwood, focuses on hands-on practice and teaches you how to use GIS and remote sensing technologies for spatial analysis and decision-making. It includes various case studies and practical exercises aimed at developing problem-solving skills, and it will be used for assignments in the latter part of the course. Lastly, the third supplementary textbook is Fundamentals of Remote Sensing. Published by Environmental Canada, this book covers the fundamentals of remote sensing, introducing both the theoretical foundations and various application cases. It is an essential resource for understanding the basic principles and technical elements of remote sensing, helping you to solidify your foundational knowledge in this field. The 3 textbooks will be used complementarily in the course. You will learn theoretical foundations and digital image processing techniques through the main textbook, and enhance your practical skills and applications with the supplementary textbooks. By fully utilizing the strengths of each textbook, the course will be designed to provide a balanced education in the theory and practice of remote sensing and GIS. If you make good use of these textbooks in your studies, you will develop the confidence and skills to apply what you've learned to real-world scenarios in the field of remote sensing and GIS. I look forward to a semester of deep and thorough learning with these resources.
Let me briefly introduce the main contents of each chapter of the textbook Remote Sensing and Digital Image Processing. This book covers a wide range of topics, from the basics of remote sensing to the latest technologies, and it is structured to help you systematically learn the essential knowledge required in the field of remote sensing. In the first chapter, an overview of remote sensing and digital image processing is provided. It covers the basic concepts of what remote sensing is and why digital image processing is important. This chapter offers a general explanation of the definition of remote sensing, its applications, the necessity of digital image processing, and how remote sensing data is collected and processed. Through this, you will establish a foundational understanding of remote sensing and digital image processing and gain a comprehensive overview of the field. The second chapter discusses how remote sensing data is collected. You will learn about the sources of remote sensing data and the various remote sensing satellite and sensor systems. This chapter specifically explains which satellites and sensors are used, what kind of data they collect, and how this data is utilized. For example, it covers major satellite systems such as Landsat, SPOT, and MODIS, and their roles. This will help you understand the process of collecting remote sensing data and its importance.
In the third chapter, the focus is on the hardware and software required for digital image processing. It provides detailed explanations of basic computer hardware components such as the CPU, RAM, and large-capacity storage devices, as well as the functions and applications of digital image processing software. You will also learn how to select and use the most important software and resources for image processing. This chapter will greatly help you build a foundation for effectively processing remote sensing data. The fourth chapter covers methods for evaluating the quality of image data collected through remote sensing and analyzing it statistically. When processing and analyzing high-resolution and low-resolution images, you will learn which indicators can be used to evaluate quality and how to interpret these evaluation results. Through this, you will understand how to enhance data reliability and improve the accuracy of remote sensing analysis. In the fifth chapter, you will learn how to visualize remote sensing data in various ways. This includes understanding color systems such as RGB and IHS, terrain visualization, and methods for representing spatial data. Additionally, you will acquire techniques that help simplify the understanding of complex data through scientific visualization. This chapter will help you develop important skills to more effectively communicate and analyze remote sensing data. The sixth chapter delves into the basic principles of electromagnetic radiation and radiometric correction techniques in remote sensing. You will learn about the mechanisms of absorption and emission of electromagnetic radiation and the radiometric correction methods based on these principles. During this process, you will understand the importance of radiometric correction in improving the accuracy of remote sensing data and develop the ability to apply it in practice. The seventh chapter focuses on geometric correction of remote sensing images. Various distortions can occur during the collection of remote sensing images, and geometric correction is the process of adjusting these distortions to obtain accurate geographic location information. In this chapter, you will learn about orthorectification of satellite images, mosaic creation, and various geometric correction methods. Through this chapter, you will learn how to correct geometric distortions in images to perform accurate analysis. The eighth chapter deals with techniques for emphasizing important features in remote sensing images. Image enhancement is used to more clearly visualize specific information within remote sensing data. In this chapter, you will learn how to better interpret images through contrast stretching, band combinations, and various filtering techniques. This will equip you with the ability to analyze and visualize data more effectively. The ninth chapter discusses the extraction of thematic information and pattern recognition in remote sensing data. In this chapter, you will learn about classification of thematic information, such as land use, change detection, and various algorithms and methodologies for pattern recognition. Through this process, you will develop the ability to use remote sensing data to solve.
In the 10th chapter, the focus is on analyzing remote sensing data and extracting information using artificial intelligence techniques. Various machine learning methods, such as decision trees, regression trees, random forests, and support vector machines, are introduced. These techniques are very useful for discovering new patterns in remote sensing data and solving complex problems. This chapter also explains how methods like neural network analysis and arithmetic rules can be applied, along with introducing recent research cases utilizing artificial intelligence. Through this, you will acquire the skills needed to analyze remote data more precisely. The 11th chapter covers methods for extracting various types of information from remote sensing data using imaging spectroscopy techniques. It introduces the latest technologies such as the use of hyperspectral data from aircraft and satellites, and spectral unmixing analysis. You will also learn how more precise analysis can be achieved through methods like spectral library matching and machine learning-based hyperspectral analysis techniques. This chapter emphasizes the importance of spectral analysis in remote sensing by covering techniques for processing and analyzing complex spectral data for real-world applications. In 12th chapter, change detection techniques using remote sensing are explained. Change detection is used to detect and analyze changes in the Earth's surface or man-made structures over time. This chapter introduces methods for performing change detection using the latest tools such as ESRI's Change Matters, as well as change detection techniques using LiDAR and OBIA, object-based image analysis. Various algorithms and techniques necessary for detecting these changes more precisely are also discussed. Through this, you will develop the ability to monitor various change processes, such as terrain changes or urban development. Lastly, the 13th chapter deals with methods for evaluating the accuracy of thematic maps generated through remote sensing. Thematic maps are geographic information maps created by interpreting remote sensing data, and their accuracy is crucial. In this chapter, you will learn various methodologies for measuring and evaluating the accuracy of thematic maps generated from single-date or multi-date images, particularly by using tools such as confusion matrices to assess the reliability of thematic maps. You will master the key techniques necessary to provide accurate and reliable geographic information.
Now, let me introduce the main contents of the workbook Making Spatial Decisions Using GIS and Remote Sensing, which will be used as a supplementary textbook. This workbook is practice-oriented and helps you learn various techniques for making spatial decisions using GIS and remote sensing data. The book is composed of 10 modules, and each module allows you to grasp important concepts through practical projects. The first module teaches you how to enhance remote sensing images. The primary goal of this module is to make images clearer and easier to analyze. You will practice displaying and enhancing Landsat images of the Chesapeake Bay and Las Vegas area through 2 projects. This will allow you to learn the basic concepts of image processing and how to apply them in practice. The second module covers the creation of composite images. A composite image is a technique that combines data from multiple bands into a single image. In this module, you will practice generating multispectral images of the Chesapeake Bay and Las Vegas area. This technique is useful for emphasizing specific band information or uncovering hidden patterns. The third module focuses on spectral signatures. A spectral signature refers to the unique pattern of reflection or absorption of each material at specific wavelengths. Through 2 projects, you will learn how to investigate and analyze the spectral signatures of the Chesapeake Bay and Las Vegas area. This process is essential for accurately identifying the characteristics of a particular object or area. The fourth module deals with land cover analysis. In this module, you will learn how to classify and analyze the land cover status using remote sensing data. Through 2 projects, you will analyze the land cover of Loudoun County and the area around Lake Mojave, comparing it with the standards of the USGS. This will allow you to experience the actual process of land cover analysis using remote sensing data. The 5th module covers unsupervised classification. Unsupervised classification is a technique that groups data without prior knowledge. In this module, you will practice performing unsupervised classification using data from the Chesapeake Bay, Las Vegas area. This technique is useful at the early stages of data analysis and helps in discovering hidden patterns within the data. The 6th module focuses on supervised classification. Supervised classification is a technique that classifies data into specific categories based on prior knowledge. You will practice performing supervised classification using training data for the Chesapeake Bay and Las Vegas area. This technique plays a crucial role in data analysis with specific objectives.
In Module 7, the focus is on classification accuracy. When classifying remote sensing data, evaluating its accuracy is extremely important. In this module, you will practice how to assess classification accuracy using land cover data from the Chesapeake Bay and Las Vegas area. Through 2 projects, you will apply various classification techniques and learn how to validate and interpret the results. This process will help you develop the ability to analyze remote sensing data more accurately and reliably. Module 8 covers methods for analyzing urban change. Urbanization is one of the most significant phenomena affecting the environment and ecosystems. In this module, you will carry out projects that analyze urban changes in Loudoun County and the Las Vegas area. By utilizing remote sensing data, you will identify patterns of change in urban areas and evaluate the environmental impacts of urbanization. Through this exercise, you will develop the ability to monitor and analyze various issues related to urban development using remote sensing. Module 9 focuses on the monitoring and analysis of water resources. Water resources are vital to both ecosystems and human life, and monitoring their changes and conditions is crucial. In this module, you will conduct projects that measure the impact of drought on Texas reservoirs and analyze the water temperature of Minnesota lakes using thermal infrared data. Through these projects, you will learn about the potential applications of remote sensing in water resource management and how to apply remote sensing data to solve real-world water resource issues. Finally, Module 10 covers the use of the Normalized Difference Vegetation Index, NDVI, to analyze environmental changes. NDVI is a widely used indicator for monitoring the health of vegetation. In this module, you will undertake projects that analyze drought conditions and seasonal changes in Texas and Minnesota using NDVI. By working with NDVI-based analyses, you will develop the ability to identify changes in vegetation and their causes, equipping you with practical problem-solving skills related to environmental monitoring.
Let me introduce the main contents of another supplementary textbook, Fundamentals of Remote Sensing. This book covers a wide range of topics from the basic concepts of remote sensing to various application fields, serving as an essential resource to help you build a solid foundation in the field of remote sensing. The textbook is divided into 5 major chapters, each addressing essential elements of remote sensing. The first chapter introduces the basic concepts of remote sensing. Here, you will learn what remote sensing is, and how electromagnetic radiation interacts with the atmosphere. The chapter also covers the differences between passive sensing and active sensing, the characteristics of images, and helps you understand the basic terms and concepts used in remote sensing. This chapter is a crucial part of gaining a comprehensive understanding of remote sensing. The second chapter focuses on the various sensors used in remote sensing. It covers the positions and sensors on the ground, in the air, and in space, as well as the technical features of satellite resolution, spectral resolution, and radiometric resolution. The chapter also explains multispectral scanning, thermal infrared imaging, and various meteorological and ocean observation satellites. This chapter will deepen your understanding of sensors, which are the key tools for collecting data in remote sensing. The third chapter deals with microwaves and radar technology that utilizes them. You will learn about the basic principles of microwaves, viewing from a geometric perspective, and the characteristics and applications of microwave imaging. Specifically, you will study how radar can be used to analyze terrain and structures, as well as the roles of airborne and space-based systems. This chapter will help you understand the potential of active remote sensing using microwaves. The fourth chapter covers methods for analyzing remote sensing images. You will learn about visual interpretation, digital processing, pre-processing steps, image enhancement and transformation, classification, and integration processes. This chapter teaches you how to interpret remote sensing data and extract and analyze the necessary information. Through this, you will develop the ability to apply remote images to various practical tasks. The final fifth chapter discusses real-world applications of remote sensing. You will study various application cases related to agriculture, forestry, geology, hydrology, oceans and coasts, land cover, and mapping. This chapter helps you understand how remote sensing technology is utilized in solving practical problems. By learning about the remote sensing techniques and methods appropriate for each application field, you will realize the broad range of applications for remote sensing.
Let me explain the weekly lecture plan for this semester. In the first week, we will introduce the basic concepts of remote sensing. We will start by understanding what remote sensing is, along with its definition and purpose. During this time, we will also cover electromagnetic radiation and the electromagnetic spectrum. These basic concepts are among the most important principles in remote sensing, explaining how to obtain various environmental information through interaction with the atmosphere. Additionally, understanding the relationship between radiation and objects in remote sensing is crucial. In this course, we will learn the difference between passive and active sensing and how various remote sensing techniques are used. Lastly, we will discuss the characteristics of remote sensing images and the role they play in practical data analysis. In the second week, we will dive deeper into the sensors used in remote sensing. You will learn about the characteristics of various sensors located on the ground, in the atmosphere, and in space, and what kind of data each sensor collects. This will include the technical specifications of satellites, such as spatial resolution, spectral resolution, and radiometric resolution. Additionally, you will learn about multispectral scanning, thermal imaging, and terrain distortion. This course will cover various types of sensors, such as meteorological satellites, ground observation satellites, and ocean observation satellites, along with their application cases. We will also discuss the role of cameras, aerial photography, and the importance of data reception. Through this week's lectures, you will gain a deep understanding of how sensors operate in remote sensing, what data they collect, and how this data is used in analysis. In the third week, we will focus on microwaves. Microwaves play a critical role in remote sensing, especially in radar techniques. The core of this week's lecture will be understanding the basic principles of radar, the relationship between electromagnetic waves and spatial resolution, and the interaction with objects. You will learn how microwaves detect the characteristics of objects and explore their application possibilities. Additionally, you will study practical data analysis cases using microwaves through techniques such as polarimetry. Lastly, we will compare the use of microwaves in airborne and satellite systems, explaining their advantages and disadvantages. Through this week's lecture, you will gain a practical understanding of how microwave technology is applied in remote sensing and how it can be used in various fields.
In the fourth week, we will cover the key techniques of image analysis. Here, you will learn various methods for interpreting and analyzing remote sensing data. The main topics include visual interpretation, digital processing, and pre-processing. You will also learn how to enhance and transform image data, and how to perform classification and composition using these techniques. Through this process, you will acquire the skills to analyze remote sensing data and extract meaningful information. In the fifth week, we will explore the application fields of remote sensing. Remote sensing is utilized in a wide range of fields, and this week we will focus on key application areas such as ice monitoring, land cover, terrain analysis, and ocean and coastal management. We will also examine how remote sensing is applied in agriculture, forest management, geological surveys, and hydrology, gaining an understanding of how remote sensing technologies are utilized in each field. Additionally, this week will include an overview of Module 1, enhancing images from the workbook to prepare you for the practical exercises. Starting from the sixth week, we will begin the practical exercises from the workbook. We will present the practical content of Module 1, enhancing images, and provide an overview of Module 2, composite images. Through this, you will learn the techniques for creating composite images and how to use data more effectively. In the seventh week, we will present the practical content of Module 2, composite images, and provide an overview of Module 3, spectral signatures. You will learn how to identify specific materials or objects through spectral signature analysis, and how to apply these methods to real-world cases. In the eighth week, we will present the results of Module 3, spectral signatures, and provide an overview of Module 4, land cover. Through this, you will learn how to classify various terrains and land cover conditions.
In the ninth week, we will focus on Module 4, land cover, and Module 5, unsupervised classification. First, we will share the practical results from the land cover presentation, where you analyzed and classified land cover conditions. Through this process, you will acquire important skills for understanding land use, terrain changes, and more. Following this, we will introduce Module 5, Unsupervised Classification, explaining the unsupervised learning techniques used to classify data into groups without prior knowledge. This plays a crucial role in the early stages of data exploration. In the 10th week, we will present the results from Module 5, Unsupervised Classification, and provide an overview of Module 6, Supervised Classification. You will present the process of grouping data collected using unsupervised learning techniques and share the insights gained. Then, we will explain the overview of supervised classification, where you will learn how to classify data into specific categories using prior knowledge. This is an essential skill for data analysis aimed at achieving specific goals. The 11th week consists of presenting the results from Module 6, Supervised Classification, and providing an overview of 7, Classification Accuracy. You will present the results of data classification using supervised learning techniques and share the methods for evaluating them. Following this, we will explain the overview of classification accuracy, where you will learn how to assess the accuracy of classified data. This is a critical process for ensuring the reliability of remote sensing data. In the 12th week, we will present the results from Module 7, Classification Accuracy, and provide an overview of Module 8, Urban Change. You will present the results of classification accuracy assessments and discuss ways to enhance the reliability of data analysis. Then, we will explain the overview of urban change, where you will learn how to monitor and analyze the process of urbanization and its environmental impacts. This is a very important skill for urban planning and environmental protection. The 13th week will cover the presentation of Module 8, Urban Change, and provide an overview of Module 9, Water. You will present the results of urban change analysis, gaining an understanding of the impacts of urbanization. Then, we will explain the overview of the water module, introducing remote sensing technologies related to water resource management. In particular, you learn how to monitor extreme hydrological events such as droughts and floods. In the 14th week, we will present the results from Module 9, Water, and provide an overview of Module 10, NDVI. You will present the results of analyzing water-related data, gaining an understanding of the importance of water resource management. Following this, we will explain the overview of the NDVI, Normalized Difference Vegetation Index, Drought Index, where you will learn how to monitor vegetation conditions using this index. This is an important indicator widely used in agriculture, forest management, and environmental monitoring. Finally, in the 15th week, we will present the results from Module 10, NDVI. You will share the practical results of using NDVI and discuss methods for analyzing vegetation changes and their causes. This will bring together all the content learned throughout the semester, allowing you to acquire practical remote sensing techniques. That concludes the explanation of the lecture plan from the 1st week to the 15th week. Through the lectures each week, you will learn remote sensing technology comprehensively by integrating theory and practice, and develop the ability to apply these technologies in real-world scenarios. I hope that the knowledge gained this semester will greatly contribute to your academic growth and improvement in practical skills. This concludes the overview of the Hydro Remote Sensing course.